So here's the last example that we have for this topic today, where we have an application of a roller coaster that is going down the track and taking a dip that is 25 meters from the highest point, and then determine the velocity, its finish point, which is 20 meters below the original starting point. So let us start by identifying where is our lowest point. So far the lowest point is at the dip of the track, and let's call this one our level 0. So level 0, which is also our h, that is equivalent to 0. So therefore our starting point h is 25 meters. However, the elevation of our endpoint is not at 20 meters, but instead it's the difference between 25 and, so this is our HF, which is our final height, that is 25 meters minus 20 meters, so therefore that will be 5 meters above our lowest point, or also known as level 0. So let's highlight so you can see the information. So question is, what is the velocity at the final or at the finish line? Again, do the same step. Initial condition. We have height initial, which is equivalent to 25 meters. Initial velocity, which is also 0. While on the other side, final condition, height of final is measured at 5 meters, as it states right there. And our final velocity is something that we want to solve for. So we are going to solve for the final velocity. So let's start with the initial state. Total energy is equivalent to potential energy initial plus kinetic energy initial, where we have potential energy initial is equivalent to mghi, and that is mass times g times initial height of 25, plus the kinetic energy initial, which is 1/2 mv squared but since 1/2 mass and our final velocity, our initial velocity is 0, so therefore our answer is 0, while our initial potential energy is measured at 25 mg. So let's add those two values together. So we have a total energy that is 25 mg. For final condition, total energy equals potential energy final plus kinetic energy final. This point, our potential energy final is mass times g times hf, which is equivalent to mg times 5, or we have 5 mg, plus the kinetic energy final, which is 1/2 mvf squared. And then we just have to add those two values together, so the total energy is simply 5 mg plus 1/2 mvf squared. Let's equate those two values together as they are equal to each other. TE equals TE. So that will give us 25 mg equals 5 mg plus 1/2 mvf squared. Let's subtract 5 mg on both sides of the equation. So this will give us 20 mg equivalent to 1/2 mvf squared. So we want to get rid of m on both sides of the equation by dividing it by m. And at the same time, I want to get rid of 2 on one side to leave our v sub f by itself by multiplying both sides by 2. So 2 times 20, that will give us 40 times g equals v sub f squared. Take the square root of both sides. So therefore, we can have square root of 40g equals v sub f. But the value of g is 10. So therefore, we can say 440 times 10 is equivalent to v sub f. So 400 square root of 400, we all know that square root of 400 is 20. So that is 20 meter per second. So this will be our final answer in terms of the final velocity of the problem with a roller coaster that is to be released at a height of 25 meters, dropping to 25 meters, going back to 5 meters, and then on a straight track that is on a straight track, and then end to rest.